Hi friends, in this video I am going to tell you the how to remember the formulas which are there in the module 5 numerical methods. So usually mathematics will be tough if you forget the results, important formulas. If you remember easily, it will be the easy subject and easily you can solve the problems. So here you should create your own tricks to remember all these results. So here let us go with advanced calculus numerical methods subject module 5 numerical methods. So here in this module you are going to learn a concept called numerical integration. So in numerical integration means whatever the given integral is there which is not going to solve by applying the standard results, whatever you know certain standard results, that is 20 to 30, 30 to 40 standard results. If those formulas are not applicable, you need to think of numerical technique. So numerical technique means it is a step by step simple procedure by which you are going to get the value of definite integral without applying the integration result. So let us consider this one. So here I equal to definite integral y dx from a to b. If this is the given definite integral, so here the interval is a to b. It is over the interval a to b. If the question is divide the interval into n equal parts and evaluate the integral. So divide the interval ab into n subintervals or n intervals, then we need to find h. H means the formula for h is b minus a by n. H equal to b minus a by n. So here you need to denote the values whatever after division. So a, so here x naught means first value, so that itself is a. So x1 is, it is x naught plus h, then x2 which will be x1 plus h. So like this will go up to xn, so that itself is b, last value. So if you divide the interval by taking h, b minus a by n, you are going to get the x values. So once you get x values, so using x values, so you construct a table. So x values here are x0, x1, x2, so on up to xn. So we know here in this integral y is function of x, y equal to f of x. So in y substitute x0. So when you substitute x0, you are going to get the corresponding y0. When you substitute x1, you will get corresponding value y1. So like this y2 up to yn, you are going to get these results. So here you are going to learn three techniques. One is Simpson's 1/3 rule, another one is Simpson's 3/8 rule, then Wedel's rule. So what we can do is, all of you know the number 143, but here you need to remember the number 142. So that is the lucky number which is associated with Simpson's 1/3 rule. Then when you subtract by 10, it is 132. Then in Wedel's rule you need to remember the lucky number 1516. So now let us start. Simpson's 1/3 rule. 1/3 rule, the integral value directly we can write I as 1/3 means h by 3 into bracket. Similarly, Simpson's 3/8 rule means I equal to 3h by 8. Then Wedel's rule, 310 rule, we call it as 310 rule, I equal to 3h by 10 into bracket. So now here 142 are associated with 3 brackets. So 1 into 1 bracket, 4 into another bracket, then 2 into last bracket. So here, then here also 132, 1 into 1 bracket, 3 into second bracket, 2 into last bracket. Then Wedel's rule 1516. So here the whatever the values are there which we got y0, y1, y2 up to yn, write as it is y0, y1, y2, y3, y4, y5, y6 and so on. So here the coefficients of these terms should be 1516. First one 1, second one 5, 1 5, then 1 6, 1 5, 1 6, like that. This is how we need to construct formula for Wedel's rule. So Simpson's 1/3 rule, first 1 4 2, first bracket, second bracket, third bracket, multiples are 1 4 2. So 1 means, so first and last value y0, yn, y0, yn, first and last values, then multiples of 2. Multiples of 2 are y0 is covered, so 2 4 6, y2, y4 and so on, y6 and so on. Then middle bracket, remaining terms, so y0 covered, y2 covered, y1 remaining, so y1, then y3, y5 and so on. Like this we write Simpson's 1/3 rule. Then 3/8 rule, here first bracket again, first and last value y0 and yn, then last bracket multiple of 3, y3, y6, y9, y12 and so on. Remaining values middle bracket, so y0 covered, y1, y3 covered, so y1 plus y2 plus y3 covered, y4, y5, 6, like that. So you need to write in middle bracket. This is how we can remember some technique, certain technique we can develop on our own to remember such results. So another important thing is Simpson's 1/3 rule is applicable when n is multiple of 2. When n is multiple of 2, we apply Simpson's 1/3 rule. So 3/8 rule, when n is multiple of 3. So if multiple of 3, you need to apply this result. For example, divisions, 3 divisions, 6, 9, 12, 15 divisions, like that. And Wedel's rule is applicable when n is multiple of 6, n equal to 6m, means when the number of divisions are 6, 12, 18 and so on. We apply Wedel's rule. Now let us understand how to write Newton's forward and backward interpolation formulas. So these formulas are applicable for a given set of x and corresponding y values. So whenever the x values are x0, x1, x2, so on up to xn, and the corresponding values of y are y0, y1, y2, so on up to yn, the question is find y at some x which is not there here. So when in this case you need to go for forward and backward interpolation formulas. So before going to forward and backward interpolations, just check the values are equidistant or not, in the sense x0, x1, x2, so on up to xn, like 10, 20, 30, 40, 50 and so on up to 100. In the sense the difference between two consecutive values are, it will be same throughout. So that value itself is called h. H means some x1 minus x0 or x2 minus x1. So in equidistant case only we need to apply Newton's forward and backward interpolation formula. So here, before applying the formula, first check whether the whatever the y you are finding at some x, that x is in first half or second half. In the sense, if x is near x0, then you need to apply Newton's forward interpolation formula. So whatever the x is there, to find y at x, where that x is near xn, near last value, then you need to go for Newton's backward interpolation formula. So now before going for formula, forward and backward interpolation formula, you need to construct the difference table. Difference table means simple, the subtraction you need to do it. If you know subtraction, you can construct the difference table. Here x values are, you write column wise, first column x0, x1, x2, so on up to xn. Similarly, y values y0, y1, y2, so on up to yn. So just what you need to do is, first difference means take the difference y1 minus y0, you will get some value. Then y2 minus y1, second value. Lastly, if you continue like this, you will get yn minus 1, that will be another value. So in the same way, then this value minus this value, you will get another value. So this value minus previous value, you will get another value. So like this you will get some values, and at the end you are going to get last one value. So if you go like this, you are going to get values in this way. So now whatever the values in this table, you are going to get difference table. So we denote by certain notation. That notation is first one. So here delta y0, first way, this value, this delta square y0, delta q y0. So lastly delta raised to n y0. So like this we write notations. So now, so these are helpful in case of Newton's forward interpolation formula. So already I have told that. So here Newton's forward interpolation formula we apply whenever we are finding y at some x, which that x is near x0. So to find y at x, where x is near x0, near x0. If near x0, then calculate r value. R means what? So x minus x0 by h. So this r value you should know, and also these differences. If you know these differences, which you will going to get, which are going to get by difference table, then you can write the formula for Newton's forward interpolation formula. So here the formula is, it starts with these values, above values, y0, first y0 plus delta square y0, delta y0, then delta square y0, and so on. So y0, delta y0. So delta y0 multiple is r by 1 factorial, delta square r minus 1 by 2 factorial, then third term r minus 1, r minus 2 divided by 3 factorial into delta cube y0. So like this we write continuously the terms, how many we are going to get. So this is the formula for Newton's forward interpolation formula. Similarly, how to go for Newton's backward interpolation formula? So before Newton's backward interpolation formula, denote, again you need to construct the difference table where you need to consider last values. How? So yn, then this is backward difference yn, delta square yn, delta cube yn, last value delta raised to n yn. So like this, these values you need to find out by taking difference table, last values. So now again here we are finding to find y at x, where x is near xn, near last value. If near last value, you need to apply this result. So here you need to find out r means x minus xn by h. This is the r value. So now the formula how to write formula, very important. So y equal to, consider last values, first yn term, then delta yn, then delta square yn, then delta cube yn. So like this it continues. So multiple of first term, no term. Here r by 1 factorial. Delta square, here multiple is r plus 1 by 2 factorial. Next r plus 1, r plus 2 by 3 factorial, and so on. Now let us understand how to write formula for Newton's divided difference formula. So here in this case also it will be given that x and corresponding y values will be given. X like x values are x0, x1, x2, so on up to xn, and corresponding y values y0, y1, y2, so on up to yn. And the question will be find y at some x, which may be any value, but here the x values are not equidistant. If it is not equidistant, you need to apply Newton's divided difference formula, or it is also called Newton's general interpolation formula. So in this case you need to construct the divided difference table. So here, so divided difference table, D table in short it is called. So how? First thing is x values, write x0, x1, x2, so x3, so on up to xn. These are all x values, and y values y0, y1, y2, so on up to yn. So write, that is the second column, where y0 means f of x0, y1 f of x1, y2 f of x2, yn f of xn. So here first divided difference how to take? So it will be between, first denoted by f of x0 x1. So x0 x1, f of x0 x1 is, so first f of x1 minus f of x0 divided by x1 minus x0, x1 minus x0. This is how we write find divided difference f of x0 x1. Similarly f of x1 x2. So this is how we find x1 x2 is, so between these two x1 x2. So f of x2 minus f of x1 divided by x2 minus x1. So this is how we find f of x1 x2. Similarly x2 x3, x3 x4, xn minus 1 xn. So like that you can find further. These are all called first divided differences. In the same way, second divided difference between x0, x1, x2. So how it is defined? First here we have two values, x0 x1 and x1 x2. So first x1 x2. So that is equal to f of x1 x2 minus f of x0 x1 divided by x2 minus x0, last value minus first value, x2 minus x0. So then continue in the same way, you will get second divided difference. Further, third divided difference, it will be f of x0 x1 x2 x3. So this is how we find. So this is first value will be here x0 x1 x2. Next second value will be x1 x2 x3. So here f of x1 x2 x3 minus f of x0 x1 x2 divided by x3 minus last value minus first value x0. So this is third divided difference. So in the same way you can go for fourth divided difference until you get the final one value. You need to continue the divided differences. So once you get all the values, here very important thing is these values, f of x0, x0 x1, x0 x1 x2, x0 x1 x2 x3. So these values are helpful in writing the formula. So Newton's divided difference formula is y equal to or f of x equal to f of x value, first term f of x naught, first term f of x naught, second term f of x naught x1, x naught x1, next third term f of x naught x1 x2, next fourth term f of x naught x1 x2 x3, and so on. So here how to complete the formula? First term f of x naught as it is, then f of x naught x1, here the multiple is x minus x naught, leave last value x minus x naught, leave last value x2, if you leave it, so x minus x naught, x minus x1, then here also leave last value, remaining is x naught x1 x2. So here you need to write the multiples, x minus x naught, x minus x1, x minus x2. This is how you need to write the Newton's divided difference formula. Let us understand how to write Lagrange's interpolation formula. So whenever here if the question is find y at some x, where given thing is x values will be given, corresponding y values will be given, by using this find y at x by Lagrange's interpolation formula. So how to write formula in case of Lagrange's method? Here try to understand how many set of points are given. 3 set of points are given. So to find y means y at f of x at x. So here 3 terms, so we can write simply one divider y naught, a divider y1, a divider y2. So now here 3x values means 2 differences, so x minus x, like this, x minus x, denominator also 2 differences, x minus x, x minus x, x minus x, x minus x, x minus x. So numerator denominator 2 differences, x minus x, x minus x, like this. So now here y naught, if y naught, write directly not here, not here y1, so write this subscript 1, here y2, so write here 2 subscript 2. Now how to complete the formula? So if not is there, leave not, remaining is 1 2, so 1 2 1 2 1 2, here 1 is there, if leave 1 0 2, so here 0 2 0 2, here 2 is there, so leave 2 0 1 0 1. So like this we write Lagrange's formula. So now let us interchange y and x. So now if you want to find x at some y, if you are finding x at some y, so write expression as x equal to how many? 3x terms. So divider x naught plus divider x1 plus divider x2. So numerator denominator differences. So here already x we have written, so y minus y, y minus y, denominator y minus y, y minus y, 2 differences, y minus y, y minus y, like this, y minus y, y minus y, y minus y, y minus y. So like this we can write y minus y. Here not, if not you write first term subscript as not, here 1, so write here 1, here 2, write 2 here. Now remaining, how to complete the formula? If not is considered, remaining is 1 2. So 1 2 1 2. Here 1 is there, so leave 1 0 2 0 2 0 2. Here 2 is there, so leave 2 0 1 0 1. So this is how we can find the x at some y. It is called inverse Lagrange's formula. It is called inverse Lagrange's interpolation formula. For a given equation f of x equal to 0, usually the question will be find x, find the root of the equation, find the solution of the equation by applying Newton-Raphson method. So in this method, what we need to do is, whenever f of x is given, substitute the simple values like a 1 1 2 3 4 and so on. So you will get certain values. So when you, in place of x, when you substitute simple values like 0 1 2 3 4, so some value will lead to, a value will be lead into negative, another value will lead to the positive value. So when it is like this, so we can say that there is a value in between these two which lead to 0. It means, so x root lies in a comma b, root lies in a comma b. So when one value is leading to negative, another is leading to positive, then we say root lies between a and b in this interval. So again compare these values. So whatever the f of a, f of b, compare these, which one is near to 0. So like for example, if it is minus 10 and this one is 5, so minus 10 is far away compared to 5. So if it is nearer to this, you need to consider this b value as x0. x0 means the initial approximate root. So initial approximate root, so you need to consider it as some x0 root. So once you consider this, then you go for Newton-Raphson method. First iteration or first correction, so first iteration will be x1. The formula will be x0 minus f of x0 divided by f dash of x0. This will be first approximate root. Similarly, then you go for second iteration. Second iteration means x2, which will be x1 minus f of x1 divided by f dash x1. So like this you need to continue. Third iteration x3 equal to x2 minus f of x2 divided by f dash x2. So like this if you continue, where you need to compare these two consecutive set of values. For example, x1 x2, if you are getting the same values up to certain decimal places, then you need to stop iteration. So if they are different, then you go for next iteration x3, again x4, like that you need to continue until you are going to get the root up to desired accuracy. So finally what we can say is xn plus 1 is xn minus f of xn divided by f dash of xn. So in case of Regula Falsi method, what we can do is, for a given equation f of x equal to 0, usually the question will be find root x, find the solution x. So in this case substitute simple values like 0, 1, 2, 3, 4 and so on. So one value will lead to the negative value, another will lead to the positive value. So once it is like this, we can say there exists some value which leads to 0. So means root lies between, which lies between a and b. So we can conclude that here root lies in a comma b, root lies in ab. So once you get this, once you understand root lies between ab, then you go for first iteration, first improvement, that is x1 equal to f of b minus f of a divided by f of b minus f of a. No, it's same. So what you can do is f of b multiply by a and f of a multiply by b. So the formula is x1 equal to a f of b minus b f of a divided by f of b minus f of a. So find out the first approximate root x1, first correction, first improvement. So once you get this, find f of x1. In this method, find f of x1. You will get some value. It may be positive value or it may be negative value. You may get any one among these two. So if positive, if f of x1 is positive, we can say that, and which is lies between these two. So positive value here, f of b, earlier it was positive. So now when you get this f of x1 positive, then replace b by x1. So root lies between a and x1. On the other side, if f of x1 is negative, if negative, so and this you need to replace a by x1. So x1 root lies between x1b, and again you whatever the interval, new interval you get, using new interval again you need to write the same formula, x2 equal to a f of b minus b f of a divided by f of b minus f of a. So you consider first value as a, second value as b, and again you need to go for formula a f of b minus b f of a divided by f of b minus f of a, and again we will get certain values. Compare x2 with x1. If they are same, stop iterations. If again different, you need to continue the same procedure until you are going to get the root up to your desired accuracy.